Hi, in this video I will go over another Leetcode problem called group anagrams. In the problem statement we are given an array of strings called strings, and then we want to group the anagrams together and then return the answer in any order. So basically, in a previous video I explained what an anagram is. Imagine we had a string called race, or a string race, and then another string which is care. These two words are anagrams of each other because they contain the same characters with the same frequency exactly, right? So if we had an extra e here, they wouldn't be anagrams, or if we had a missing e, they wouldn't be anagrams. Anagrams are basically two words that have the same exact characters and the frequencies, but they're like arranged in different orders, which make it a little bit tricky to identify which strings are anagrams. So for this problem, let's look at an example. In this case, we have a string of strings, basically. Let's say we had the word eat from the example, tea, and then we had 10, 8, and then gnats, and bat. Alright, so we have this string of an array of strings that has 1, 2, 3, 4, 5, 6 different strings, right? And then we want to identify which of them are anagrams, group them together, and then return. Our output is going to be an array of subarrays with strings. So the output for this problem would be, so we're going to group, first of all, we're going to group bat by itself, because I'll get to that in just a second. It's not an anagram of any other word in this list. And then gnats and tan are going to be grouped together. Then in our last subarray we have 8, eat, and tea. Okay, so as you can see, 8 has 1A, 1T, 1E, eat has 1A, 1T, 1E, and T, same thing, and so on, right? So looking at our input, and our output. So we have an array of strings, and in our output we have an array of string arrays. Right? And my initial idea was basically an easy way to identify if two strings are anagrams, or two or more strings are anagrams, is to basically just sort them. For example, if all the strings in this subarray, if you sort them, are going to be AET, AET, AET. And if you just go through this string array and then sort every string, and then basically compare them, then this would be like a brute force solution. But then let's say the string of this array we said 6, right? So this would be n by m log m, right? So n would be the length of strings, and then m is basically the size of every string in this string of array, right? So that wouldn't be an efficient solution, because for every word you have to sort it. If we have very large words, then that wouldn't be efficient. And then if our array of strings is also very large, then that's also asymptotically not an optimal solution. So before I get into the optimal solution, I'd like to mention some edge cases plus constraints. So for this problem, an important point to mention before getting into the solution is, can we assume that the input is all going to be like characters, right? English characters, lowercase. So we're going to assume it's English and lowercase characters, because we don't have to worry about like spaces or integers or special characters. And then another thing is that every string could be between 0 and then 100. So string of I dot length is equal 100. So we could have a case where we have an empty string. And in this case, we want to basically just group it with the rest of empty strings. So this is just like an edge case to keep in mind. So now for our optimal solution, so since we're going to have to use some sort of like data structure to make up for the time complexity of just going through them and going through the whole list and sorting them, well, we do need a data structure that's efficient in searching and finding, right? Because let's say we sort the string, right, and then store it as a key. Then by simply sorting this next string and then trying to insert it into this list, well, we already know that it's gonna be stored here, so we can just append it to the values, list of values. So in this case, a map would be very useful, where we can store key value pairs. For example, if we look at, let's take this test case here and use it. So yeah, let's say we start from the word eat, right? If we sort this word, it becomes AET, right? And then we know every other anagram, if we sort it, it would have the same order and combination of letters. So our key would be the sorted string. So we would have AET as our key, and then for our value, we're going to have basically an array of strings where we're going to store them all together. So EAT, right? And so on. So then we look at the next word. We have T. We sort this word, and it becomes AET again, right? So we try to insert this into the map, and then we see, oh, it already exists. So we can just append it to this list as a value for this key. So then we have T. And then we look at the next word, which is tan. So look, we're doing all this in basically one pass, but at the same time, we are sorting the strings individually inside this one pass. So this would make our time complexity n log n. For sorting, we're going to assume, or just to match what I said earlier, so m log m, where m is the size of the string, and then n for the number of yeah, basically the number of strings we have in this array. So the time complexity would be the same as if we just sort every string, but then in that case where we didn't use the hash map, we would need to do another for loop where we compare every element with each other, and that would add to our time complexity. So in this case, we're just doing it in one pass as we go and adding to this hash map. So the next word is tan, right? So tan sorted would be, I believe, ants. Yeah, n comes before t, so ant, and we're gonna append the word tan here. So you see how our output consists of these like substrings? Here we're forming them inside our map slowly just by looking at this sorted key. That's a great trick to know, like that this key will allow us to store the strings together, right? And then our next one is 8 is AET, so we try to insert it and then we find it, so we just append it to the list and we are done with our first sub-array of strings. And then we look at nat, and it should match this when sorted, so we append it over here, so it becomes nat. And finally we look at bat. This would be like ABT, and ABT is not an anagram to any other word, so we just add this here. And there you go, we have a map of all the anagrams grouped together, and all we have to do is just iterate through the values of this map and return them as one big array or vector in C++. So here we're going to look at the code solution in C++. So group anagrams, this is our function. And as you can see, we want to return a vector of string vectors, which is like a nested array. And this function takes in a vector of strings, which we just looked at. So this is our vector of strings, and then this would be our output inside one big vector. So first thing I did in my solution was initialize an unordered map with a key string and a vector of string as a value. So what is that key string? Well, this is the sorted string for each anagram, and the vector of strings is basically the list of the actual strings, right, that are not sorted. And then the solution is going to consist of all the sub vectors stored inside this vector called solution. Okay, so as you can see, in one pass we are gonna first of all sort the string, right? So what I'm doing here is basically I have this sorted string variable that would take the string at the ith index, store it, right? And then we want to sort that variable, right? So we don't want to sort the string itself. What we're doing is basically sorting the variable, which is a copy of this string at the ith index. So this is how you sort it, sort the string from beginning to end. And then what we're doing is inside the strings map, we are basically indexing into the sorted string. In this case, it doesn't exist, so it's going to create a key of the sorted string, right? And then it's going to push back. So as we're using pushback because our values are vectors. So we had a string here and vector here, right? So we push back the original string that we didn't sort. So as you can imagine, it would look like this. This is our sorted. We are either creating a key for it or just updating its value vector, right? So by doing pushback, we are adding to that vector. After this finishes running, we would have this, basically this output here, and then in another for loop, we are iterating through every pair in the map and pushing the value of every pair to the solution vector. So what this means is, okay, we have this pair first. What is pair dot second? Well, it's this whole thing. We push it to the vector. We go through this. We take its pair dot second, which is the value. We push it to the vector. And for every pair, we do that until we are done with all the pairs. Then we return the solution, and this should have all the anagrams grouped together.